A warm welcome to one and all who is gathered to listen this video. So our general topic is all about hydraulics and pneumatics. So regarding hydraulics and pneumatics, so far we have seen many sessions, so in which we have learned many things about this full topic hydraulics and pneumatics. So concerned about hydraulics, we have learned a lot, and now in today's class also we are going to learn a topic in hydraulics. So hydraulics in hydraulics, we are going to learn the topic hydraulic motors. So hydraulic motors, the topic which we are going to see today. So this topic is concerned about a movement of the vanes, the rotor, and the rotation parts. So how the movement is going to take place and how mechanical useful work is going to be done is being seen there. So before getting into the topic, we must know the general difference between a pump and a motor. So regarding pump, we know that it's a device which converts the mechanical energy into hydraulic energy. So we all know a low pressure liquid which enters initially in a pump, and the pump rotates with an higher RPM. Due to this rotation, the low pressure liquid gets converted into a high pressure liquid. That is, the velocity gets increased in this case. So due to this velocity increase, we are getting an high pressure hydraulic energy at the output of a pump. And nevertheless, for a motor, what actually happens means an hydraulic energy is converted into mechanical energy. So if you see that at the output of a pump, we can get a high pressure fluid. Okay, the high pressure fluid enters into a motor. Motor is a part which consists of various vanes. It may be consists of a gears, pistons, etc. So the high pressure liquid is influencing these vanes, gears, pistons. Then what happens means the gears, pistons, vanes rotates with an higher RPM, where the end result of a motor is a mechanical energy. That is, a useful work is being done. That useful work is then converted into a torque. It is a required torque. To do a work, we will get the required torque in it. Okay, so this much thing is being utilized in this motor. Okay, so now the topic, we're getting into the topic. The topic says that hydraulic motor or rotary actuators. So rotary actuator in the sense rotation. So due to rotation, we are actuating the thing from one place to another, or we are actuating a work. So normally actuator we all know. So it's nothing but movement. It's a mover. Okay. So it actuates a work. So for example, if we consider a human body, in a human body, we all know that there are many actuators present in a human body. Our hand, okay, two hands and the two legs are also an actuator, important actuator in our body. So what our hands functions, what does it does? What does it use for? To pick and place a thing, to hold a thing, to carry a thing. Okay, so for all the things, our hand is essential actuator in our body. So likewise, our legs. Okay, you can move from one place to another place. So we need a leg. So leg is an actuator. So likewise, we are having many actuators concerned with industries, concerned with automobile fields, concerned with the civil engineering department. So many applications are being involved in this actuators. So in that actuators, we are going to see a rotary actuator. What is a rotary actuator actually it's doing? What is its function? How does it function? Due to that function, what happens to the output work? So likewise, the topics we are going to see in this videos. Okay. So generally a rotary actuator is to convert the hydraulic energy into a rotary mechanical energy. Okay, so I just now only I explained actuator, a rotary actuator is a thing where the output from the pump, that is the hydraulic energy, high pressure hydraulic energy is sent into the motor, where the motor vanes are influenced by this high pressure liquid. Due to this influence, we can get a mechanical energy, that is a mechanical output. So that mechanical output is nothing but the useful work. Okay, so what happens actually, instead of pushing the fluid, so instead of pushing the fluid as pump do, in a motor, the rotating elements like the vanes, the gears, the pistons are pushed by pressurized fluid. The pressurized fluid, where it is coming from? It is coming from the pump. So this pump and motor are interdependent. Okay, so which depends on each other. Okay, so now we can see an image where the typical motor is shown. Okay, so inside these inner parts are shown. You can see that. So this is a cylindrical casing. Okay, so when cylindrical, you can tell that inside the cylinder we are having a piston arrangement. So inside the piston we are having a gear arrangement. So we can tell this as a gear actuator. This a gear motor we can tell. Okay, so you are having an way for fluid flow. So in this way, fluid flows and then it pushes the piston. Okay. So due to this pushing movement, the gears present here rotates. So due to this rotation, here we are obtaining a mechanical output energy. So the mechanical output energy is utilized. So we all know, due to this mechanical utilization, we can produce electricity also. So this is another one, further one big topic. Okay, this is not important to us now. So regarding the energy, mechanical energy, we are morely concerned. So we are extracting mechanical energy from this thing. Okay, right. So next you can see the classifications of an hydraulic motor. So the hydraulic motors, that is the hydraulic actuators. Okay, the rotary actuators are actually classified into two types. One is continuous rotary hydraulic motor. Another one is limited rotation hydraulic motor. So what is continuous rotary hydraulic motor? What is limited hydraulic motor? We are going to see in this video. So under continuous rotation hydraulic motor, there are three types. One is gear motors, another one is vane motors, another one is piston motors. So three different kinds of motors are present in continuous rotary hydraulic motors. And then concerned with limited rotation hydraulic motors, we are having two types. One is vane type, another one is piston type. Okay, so now we can see what is continuous rotary hydraulic motor in detail. So this continuous hydraulic motors are, the name itself implies that it's an actuator that can rotate continuously. Okay, so it's a motor that can rotate continuously, so that can produce enormous amount of mechanical energy from the useful input. Okay, the input is nothing but the highly pressurized liquid. It is coming from the pump. Okay, so enormous amount of energy is being extracted and produced in this process. And then here also we can develop high torque and produce continuous rotary motion. This we can utilize continuous rotary motion in this devices. Okay, so it is further classified. This is further classified into gear motors, vane motors, and piston motors. Okay, so now we can see the gear motors. Okay. Uh, the principle, the concept is always the same. Okay, the fluid enters in one part and the fluid exits in one part. So in between this gap, what is the work the fluid is doing? This all principle it deals is same for all motors, but the design, the way of flow, the way of flow utilization, is being differ in every motors. So under gear motors, what is actually happening means it's a motor that converts the fluid pressure. You can see that it converts the fluid pressure into rotary motion. The same principle. The fluid pressure is nothing but the hydraulic energy is converted into rotary motion. Rotary motion is nothing but mechanical energy. Okay, as simple as you can. So now what happens actually? What happens? So this is a typical view of a gear motor. Okay, so you can see this. The outer layer is a casing. Okay, this is a spiral casing in which there is two same kind of gears are present. So these are spur gears. The shape itself implies that this is spur gear. Okay, so what happens now? Our ultimate aim is to rotate this gears inside. Okay, so our input is the fluids. The fluid which is coming from the pump. Okay, the output is nothing but to produce mechanical energy. The mechanical energy is produced from this gears only. So our ultimate aim is to rotate this gears in an higher RPM. Okay, so what happens actually? The high pressure fluid is coming from the pump. As soon as the pressure fluid comes to the pump, it goes and distributes inside this chamber, where it gets influences these gears. So automatically this first gear rotates. Due to the both gears meshing, what happens? Second gear also rotates. So both gears are influenced and they are rotated in at an higher RPM. And then after the rotation completes, what happens? The fluid gets out to the outlet. Okay, so the fluid influences these gears, rotates the gears, and convert that into useful work, and then it gets left out. Okay, so from here we are extracting the mechanical energy through use of a shaft, through use of a rod, or any other mechanical devices, rotation devices. Okay, so this is the working of a gear motor, right? Okay, so the pressurized fluid from the hydraulic pump turns the motor output shaft by pushing on the gears, pistons, or vanes of an hydraulic motor. So now here we are using gears. Okay, we are using gears. Okay, so next case we'll be studying about the vanes, pistons, how this gets influenced by the hydraulic pressure, the hydraulic force, by the hydraulic fluid, and then how that is going to get converted into a useful work is what we're going to see now. Okay, right. Next thing. Second, next thing is the vane motors. So the name itself implies that it's a vane type. Vane type means it's an axial blades. So it's be having a radial blades where it is going to be influenced at an higher RPM. So like a vane pump, the vane motor operations is also same. Here, the principle remains the same, but the cases are reversed. You can see the reverse cases between this vane motors and vane pumps. Okay, so in this pump, what actually happens means the pressurized fluid acting on the vanes. Okay, the pressurized fluid which is coming from the hydraulic pump is getting influenced, that is, it is getting acted upon the vanes and causes that vane to rotate. Okay, if you are influenced by something, you are going to you tends to move. So likewise, the vanes are getting influenced by the pressurized fluid, and then it begins to rotate, and then it creates the developing torque output. That is the it creates an output. Okay, the output consists of some torque. So these kinds of motors are mainly used in low speed application than gear motors. Low speed application. So where we require less amount of speeds. So these kinds of motors are being used. So under these motors, it's classified into two types. One is balanced vane motor. Another one is unbalanced vane motors. Okay. So now we can see what is unbalanced vane motor and balanced vane motor in detail. So you can see this image. Okay, so in this is outer layer is a chamber. Okay, or it's a cylinder block, outer part. Okay, so inside we are having a spherical rotating part, and inside that you are having a rotor block. So which is very important in concern. So rotor, this is the rotating part of this devices motor. So inside the rotors, you are having inside the motors, you are having the vanes. It's nothing but the blades, the curved blades just present inside the rotor. Okay, so for an unbalanced, how the name unbalanced came here. It means the center of the rotor and the center of the vane are not same. We are having a different center. We are having a center, okay, just apart from the rotor cylinder. Okay, so we are having a different center. So due to this center, what happens actually? The forces entering in this way, the force, that is the hydraulic pressure, enters this way and it gets out this way. So what happens at the inlet, at the exit, there is an unbalanced force created. Okay, so how this unbalanced force is created means what happens actually when the hydraulic fluid enters this chamber and then it strikes the vanes. So when it strikes the veins tends to rotate. Okay, tends to rotate. So when the fluid comes with high pressure, the vanes tend to rotate at a higher speed. So due to this rotation, the rotor present inside this vanes, the rotor tends to rotate around its axis, but the axis has different center. So when this rotation takes place, what happens means there is a big gap or clearance between the rotor, sorry, the cylinder block and as well as the rotor. So what happens? This you can see the space. So this space has more gap. So what happens? The liquid fills here first. The liquid fills here. The liquid fills here. Okay, liquid fills here, and then it goes this place. When it comes to this place, what happens? This rotor it tends to move up. So rotor tends to move up. Then what happens? The liquid displaces in this place and it gets deposited here. Okay. Again, what happens? It displaces the rotor again in this position. So what happens? The rotor it displaces the rotor at every position for its one complete revolution. So the rotor also turns as well as the vanes also rotates. So due to this, there is an unbalanced force is created. Okay, so that unbalanced force is not allowing the vanes to rotate in a proper way. So it attains a speed, but we can't attain much more speed when compared to a balanced vane motor. So this is how a rotor rotates here. So due to this rotation, we are extracting a mechanical energy. Okay, this is the all about unbalanced vane motor. Okay, so the inlet enters, fluid enters and strikes the vanes and makes the vanes rotate in higher RPM. Due to this rotation, a mechanical output is produced. So after that, the fluid comes out. Okay, so this is the working of unbalanced vane motor. Okay. I hope you all understood what I told. So next, we're going to see a balanced vane motor. So from an unbalanced thing, we are balancing the forces in this motor. How we are balancing means actually we are introducing two things here. We are having two inlets, and we are having two outlets. There's two port opening and two port closing. So inlet and outlet. So here also we are having a rotor. We're having the rotor, okay, and we're having the vanes which has the same center. So that's the difference between main difference between an unbalanced and balanced vein motor. Okay, so what happens here actually? The center is same for both these parts, and the rotation in this it follows a rotation in this oval part. Due to this rotation, there is no an unbalanced force is being created in these places. Okay, so that's why they prefer this concept called balanced vane motor. Okay, so now what happens here? A pressurized fluid from the pump enters this chamber and then it strikes the vanes at an higher RPM. The vanes rotate with an higher speed. Due to this rotation, the rotor also rotates. Due to rotation of the rotor, mechanical output, this mechanical energy is produced. Okay, so here we are uh, passing the highly pressurized fluid in both directions. Okay, so what happens means it pushes the wings in a very faster rate. So when it pushes the wings in a faster rate, our mechanical energy is being increased when compared with an unbalanced wing. Okay, so what happens after the fluid enters the chamber and rotates in higher RPM, rotates the vanes in higher RPM. What happens? An exerting force is created. An exerting force is taken as the outlet. So at the outlet, an exerting force is created, and the fluid splashes at the outlets. Okay, so this is how a fluid is being gets utilized, and it makes and tends the vanes to rotate, and a mechanical energy is being produced in this motion. Okay, I hope you all understood what I told. Okay, so next thing we're going to see. Next thing we're going to see is piston motors. This is the third type of motor which is present in. So this is a third type of motor present in a continuous rotary hydraulic motor. Okay. So what happens here actually? So both before cases, the gears and vanes, the flow is coming in one direction and flowing in another direction, where it is not being stepped up or stepped down. So the flow is in a gradual way. It may be the wave may be from a left to right side or top to bottom. It may be, but here what happens from a distance from the ground level? Okay, these motors are being fixed. So it is having one end at the top and other end at the side. So this is one end and this is another end. Okay, so what happens actually? The fluid enters the chamber and then it rotates the parts. It pushes the piston inside. So due to the piston movement, what happens? This thing rotates. Okay, so this thing rotates, which is it's nothing but the mechanical work is being done. The mechanical work is being done at this part. So how actually this looks means this looks like this. So we're having the connecting part here. So it comes like this. This is the main part. Okay. So it looks like this. So fluid enters 9 RPM and pushes this piston inside it, which actuates and controls into a mechanical output. Okay. Regarding this piston motors, we're having axial piston motors, radial piston motors, as we have seen in the pump category. Okay. So the principle of working diagram wise, systematic diagram wise, all remains the same. Okay, so no issues in it. Okay, so we will go for the next topic. Next topic is limited rotation hydraulic motor. So another one important topic concerned about limited rotation hydraulic motor. So the in this also the name itself implies that there is only limited rotation involved in this casing. So the casing which is designed here, okay, inside the casing we will be having the vanes. What about the vanes? The vanes rotates in a limited way only. That is, it rotates in a limited RPM, in a limited space, at an angle, at some finite angles. The word is very important here. Finite angles. It rotates at a finite angle. So due to this finite angle, there is a restriction in the flow. The restriction in the rotation. That's why it is called limited rotation hydraulic pump. So due to some damaging issues and due to some flow rate issues, okay, what happens? The flow is rotation is being limited in this process. So what happens when this is limited and high instantaneous torque is being created in both the direction, this in either in one direction or in both the direction, and this requires very small amount of space when compared to a continuous rotary hydraulic motor. This limited rotation motor requires a small space and simple mountings are being utilized here. Whereas in a continuous rotor hydraulic motor, there's a complicated things are being complicated designs, complicated mountings, complicated cushionings are being involved. Okay. So this limited rotation hydraulic motors are further classified into vane type, piston type. Okay, now we can see one by one what is vane type and piston type. Okay, so this is the vane type motor. Okay, listen carefully. What happens here? So you are this is the casing. That is the outer covering. Okay, outer covering. So in which there is two ports. Port A, this inlet, and port B, this is outlet. Okay, so this vane type motor, this comes under this limited rotation hydraulic motor. So it resembles like a wall clock. You can see a wall clock inside. It's like a wall clock. So this is nothing but a cylindrical block present inside. Okay, and then you are having a needle-like shape. It's nothing but the veins. This looks like a puppet ball. Okay, now what happens? See, the highly pressurized liquid from the pump flows to this port A. As soon as when it flows to this port A, it get uh, when initially the cylinder block will be in this position. So what happens as soon as the fluid enters, it is being filled here. After the liquid goes down, it strikes the vein. When it strikes the vein, what happens? The cylindrical block also gets tend to rotate. Okay, so when the veins goes on rotation, it is influenced by this fluid. What happens? The cylindrical block also rotates. So when it rotates, it blocks the way the fluids flow. So what happens? Actually, it blocks this whole way. Okay, when it blocks this whole way, what happens? The fluid gets tends to go in this direction, and when the cylindrical block goes on rotation, what happens? The liquids are fully displaced out of this chamber through port B. So this port B it gets out. So our ultimate aim is to rotate this cylindrical block inside. So the cylindrical block is rotated by means of this vane. This vane is rotated by means of this pressurized liquid. This pressurized fluid. Okay. So this is a simple working of a vane type motor. So what happens actually here? The fluid enters and it pushes the vanes first, and then it pushes the cylinder block, and cylinder block rotates with an higher RPM, which in turn produces mechanical energy. that mechanical energy is being utilized and it is being converted into useful work. Was it clear? Okay. You can see the next image. In previous case, we have seen a single layer, single vein design. Now we can see a dual vein design. This is typically used, normally used vein design. So comparatively, you can see what is the difference involving means the veins are large here. The veins are large and it is placed in a dual manner. And also we are having two inlets, one inlet here, another one inlet here, and then we are having two outlets here, one outlet here, another one outlet here. Okay, so now what happens actually when the pressurized, highly pressurized fluid from the pump enters this chamber, enters this inlet. You can see this, enters this inlet. Okay, and then it comes this way. Fluid comes this way and it strikes the vein here. When it strikes the vein here, the vein part from here gets displaced and it tends to move. Due to this movement, the fluid present here is being displaced here. Okay, so next what happens? There is outlet. So in this space, the oil gets released outside. So after this oil gets released outside, that oil is getting utilized here in this inlet, and again this oil is getting into this chamber and it strikes the veins. So after that, what happens? It pushes the veins, and the liquid is present here is being displaced here. So the vein keeps on rotating, and the liquid is being filled and it's being passed out to this outlet. So what happens? The liquid is going to be fully filled in this, is going to be fully involved and filled in this chamber. So when it is being filled and involved in this chamber, what happens? The veins actually rotates. Okay. So what happens? With this rotation of the veins, the mechanical energy is being produced. So since we are having a two inlet and two outlet ports, the speed of the motor is gets further increased when compared to a single vein design. Okay, so in dual vein design, the forces multiplies, the forces multiplies, and the output work also gets very high. So this is the difference between these two things. Okay, difference between uh, a single vein type motor and dual vein type design. So you can see this diagram. You see this diagram in which the red colored portion shows the presence of fluid. The fluid presence here. This is the fluid present area. What happens when the fluid enters this chamber and with high pressure and it gets strikes the veins. So this is the vein. This is the vein present here. It strikes the vein. When it strikes the vein, this vein tends to rotate. So due to this rotation, what happens? The fluid present here gets out in this space and it's being drained out. Okay, so our ultimate aim, whatever may be the concept, the ultimate aim is to rotate these veins. So this vein. Okay, due to this rotation, a mechanical output work is being converted. So that is the main concept we are going to see here. We are seeing here. Okay, so this is a typical image of an limited rotation hydraulic actuator. This is how it actually looks. So this is a 3D model which is being designed in an AutoCAD software. So you can see this diagram. Okay. So next comes the last type, piston type. This piston type is coming from limited rotation hydraulic motor. Okay. So here compared to other things, what actually involves here means rack and pinion arrangement. So we all know a long shaft just geared and then Another one, circular gear thing. We'll be having two things. Let me clear you. Long shaft where we'll be having a gear. Okay. And then here we'll be having another one here, which both are being measured. So we can call that this as a rack and rack, and this as pinion. Okay, pinion. So this arrangements is involved here. So you can see how it works now. So this is the cylinder block, which is in a rectangular shape cylinder block. What happens here? What happens here? From the port A, the highly pressurized liquid enters, and after the entering, there is two parts the fluid is going to flow. So this is the first part. It flows. As soon as it flows, it goes and strikes the piston here. This is piston one. When it strikes the piston one, what happens? The rack present here tends to rotate at an RPM. When the rack rotates, what happens? The pinion also rotates. So pinion rotates with a certain RPM. This is one kind of flow. Another kind of flow, what happens? It is directed to this portion, and then it goes and then it strikes the piston here. When it strikes the piston here, the rack present here tends to rotate. Due to this rotation, what happens? The pinion also rotates. So you are involving two pistons. The two pistons, you are involving two rack and pinion arrangement where the rotation multiplies, goes on multiplies. So we can get a maximum of power utilization here. So maximum power utilization is being carried out here. Okay. And after rotation, what happens? The fluid comes out in this way. It comes out in this way. So this is how a piston type motor works. Okay. Where two piston, two rack and pinion arrangements are being involved here. So the mechanical works is being converted in a larger amount in this type of piston type motors. Okay. So I think you all clear in this topic. Okay. So this is all about the hydraulic motors. I hope you understood the concept of hydraulic motors. So have a good day. So see you again next session. Thank you.